Hello grade 12s and welcome back to another video. In this video, we will be looking at question number 6 from the November 2021 Physical Science Paper 1 exam. This question deals with the Doppler effect. To the top of your screen or at the top of your screen, you should be able to see the section of the formula sheet that we use for this section of work. It is actually only the first 3 formulae that we're going to make use of. The first one shows the relationship between the speed of the sound or even light to the frequency and the wavelength. Then we have a formula that shows the relationship between the period and the frequency of the light. Lastly, we have the Doppler effect. In this formula, we can see we have the frequency observed by the listener and the speed of the listener, the speed at which the listener is traveling. We have the frequency of the source, that is the device or person that is creating the sound or light, and the speed at which that source is moving. Lastly, we have the speed at which the sound or the light will be moving in the specific medium in which it is moving. Okay, so this would be the speed of sound in air, for example, or the speed of light in a vacuum. This constant is normally given to you in the question, or you can find it in your table of constants. So now we move on to the actual question, which says, the siren of a stationary ambulance emits sound waves of or at a constant frequency of 680 hertz. The siren is stationary, and the siren is the device that is creating the sound. So therefore we can say it is the source, and the speed of the source is 0 because it is stationary. The 680 hertz is the frequency of the source given as 680, and we're going to label this or write it down on the side, because if we label everything, it makes it a lot easier for us to find the information that we need to use to perform calculations in the questions that follow. Now they say a man is standing. If he is standing, he's standing still, with a detector that records the wavelength of the sound emitted by the siren. So the detector is going to be the listener. That is the device that is detecting the wavelengths. Remember that the symbol that we use for wavelength is lambda. So this detector is not detecting frequency, but rather the wavelength. They say that the man is standing, so therefore we expect that at this point, the man who is standing with the detector, which is the listener, is going to have a speed of 0. They say the speed of sound in air is 340 meters per second. This is the value of V, the constant in your formula. Now 6.1 says, calculate the wavelength of the detected sound. If the device, the listener, is stationary and the source is stationary, then it means that the detector will detect the true frequency and therefore the true wavelength of the sound. So we simply need to use this value in a formula and determine its wavelength. You'll remember from the top that this is the formula that shows the relationship between speed, frequency, and wavelength. So we're going to be making use of that formula. We start off by writing it down. V equals F multiplied by lambda, which is the wavelength. The speed of the sound in air is 340 meters per second. The frequency is 680 hertz, and we are looking for the wavelength. When we manipulate this formula, we find that the wavelength is equal to 0,5, and wavelength is measured in meters. For this calculation, you're going to get 1 mark for your formula, 1 mark for your substitution, and 1 mark for your correct answer, of course, with the correct SI unit. Question 6.2 begins with new information. They say the ambulance now moves at a constant speed along the road towards the man. Immediately now, I'm going to go up to the sketch that was given to us, or the diagram that was given to us. I'm going to remember that the siren, and therefore the ambulance, is no longer stationary. And I'm going to indicate on the sketch that the ambulance is moving towards the man. That is what is happening at the moment. The man, however, is still stationary. They say the detector now records the wavelength of the sound, which differs from the previous reading by 0.05 meters. The wording here, the wording used here, is very important. They don't say that the new wavelength is 0.05 meters. They don't say that the new wavelength becomes 0.05 meters. Instead, they say the new wavelength differs from the previous one by a value of 0.05 meters. So we are either going to be adding this value or subtracting it from the previous wavelength that we calculated in question 6.1. And I'm going to do that immediately so that I don't forget. Let's analyze the situation. If the ambulance is now moving towards the man, is the device that is in the man's possession going to detect a larger, so I'm going to ask the question firstly in terms of frequency, because I know most of you think in terms of frequency. Is the man going to detect, is the device, the detector, going to detect a frequency that is higher than the true frequency of the source? Or is this value, the frequency that the device is going to detect, lower than the frequency of the source? The correct answer is, because the ambulance is moving towards the man, the frequency that the detector is going to detect is higher than expected, or higher than the true frequency. So, if frequency increases, if we have a higher frequency, what does that say about the wavelength? We know that the frequency and the wavelength, have a relationship where when the one increases, the other one decreases. So a higher frequency implies that the wavelength that the device is going to detect is lower than the true wavelength of the sound. Therefore, grade 12s, we're going to say now that the wavelength, not the frequency, but the wavelength detected by the listener, which is the detector actually, is going to equal to the original 0.5 minus, because there's a difference, minus 0.05 meters, which gives us an answer of 0.45 meters. This is the new wavelength, or this is the wavelength that the detector will detect, And we perform this calculation immediately when we get the new information, so that we don't get confused at a later point when even more information may be given to us. Now they say, question 6.2, state the Doppler effect. This is a very long statement. We say the change in the frequency, or you can say pitch or wavelength, of the sound detected by listener because of the sound source and the listener because the sound source and the listener have different velocities relative to the medium of sound propagation. So basically we're saying that because the source or the listener, or the source and the listener, are moving relative to the air in which the sound is traveling, the observed frequency is going to change. Or we can say the apparent change in the observed or detected frequency, pitch, or wavelength as a result of the relative motion between a source and an observer or listener. If I were you, I would learn the second version off by heart because it is shorter, but that is completely up to you. For writing down the statement, you're going to obtain 2 marks. And remember, if the sections that are underlined are not included in your statement, then you're going to lose the 2 possible marks. Question 6.3 now says, how would each of the following have changed when the ambulance approached the detector compared to when the ambulance was stationary? choose from increased, decreased, or no change. And grade 12, you simply need to write down the words increased or decreased or no change. You don't need to expand any further. Please follow the instructions. Question 6.3.1 says the distance between the wavefronts. They've asked this question a bit differently from what you're used to. Instead of just saying the wavelength, they say the distance between the wavefronts. This is the wavelength. They're asking us, how will the wavelength observed or the wavelength detected change? We already spoke about this when we were dealing with the information provided above question 6.2. And we know that since the ambulance is approaching the man, the wavelength is going to decrease. So we write down the word decreased. Then they ask, how will the frequency of the detected waves change? The frequency is going to be FL. We don't need to write that down in our answer, of course, but we know that when an object, when they move towards each other, when the one object moves towards the other, then the frequency detected is going to increase. And as you can clearly see here, we have the same relationship I spoke about a moment ago. When the frequency increases, the wavelength decreases. We can of course write down the word decreased because they use the past tense in their instruction. Question number 6.4 says, calculate the speed of the ambulance, where the ambulance is the vehicle that has a siren, and that siren is the source. So we are looking for Vs, the speed at which the source is moving. We start off by listing the information that we have. We were given that the speed of sound in air is 340 meters per second. We know that the detector is at rest and therefore has a speed of 0. The wavelength detected by the detector is 0.45 meters. We write down this calculation on our answer sheets just in case it will give us a mark. So remember, they said that what the detector detects after the ambulance starts moving differs from the original wavelength by 0.05 meters, and that is why we perform this calculation. On that note, we actually do not know the frequency detected by the device. We know that the frequency of the source, the sound that the siren is emitting, is 680 Hertz, and we are asked to calculate the speed at which the siren, or in other words, the ambulance, is moving. We start off by remembering that we're going to be required to use the Doppler effect in order to answer this question. And just like I mentioned in the previous video, you see over here at question number 6.2, they asked us to state the Doppler effect. And normally this implies or gives us an indication that we're going to be making use of the Doppler effect at a later stage in the question. Normally directly after, but over here it is 3 questions later. So we start off by writing out the formula for the Doppler effect. I do suggest that you always write down this formula exactly as it is given on your formula sheet with the plus and minus symbols, because if you make a substitution error or you choose your signs incorrectly, then at least you'll be able to obtain your formula mark. Now let's see what we have. We have this value. Over here we have that one. We know this value, but we are looking for, our interest is in that value. The frequency of the source we have as well. But we have a problem. In order to find this unknown, we also need to know the frequency of the listener, the frequency that the detector detects. All that we have at this point is the wavelength detected by the device. So we need to start off by calculating the frequency. And to do so, we're going to make use of this formula again, V equals F multiplied by lambda. We plug in the values that we know. That is 340 is the speed of the sound. The frequency we do not know. The wavelength is 0.45. When we manipulate this formula, we find out that FL is going to be equal to 755,56 hertz. So that is the frequency that the device is detecting. So now we know this value as well, and we can plug everything that we have into the formula. 755,56 is equal to 340. Now we must choose the signs. Actually, before we even substitute values into the formula, let's choose the signs. We have that the ambulance is moving towards the listener, and therefore the detected frequency is higher than the frequency of the source. So in order to make the fraction big, we're going to choose a plus sign at the top and a minus sign at the bottom. Okay, so now we substitute into this formula the values. We have 340 plus the speed of the listener is 0. So you can say plus 0, or you can leave that out of the equation completely. Divided by, we still have 340 because that is a constant given to us. Minus Vs is what we're looking for. The frequency of the source is what we were given as 680 hertz. So we plug that in. Now, I often find that learners struggle to manipulate this formula when the unknown is at the bottom, which is very sad because this is something that you learn to do in mathematics. But I'm going to take you through the process so that you can avoid making silly mistakes in your exam. See, we need to get this in a numerator position. We need to get it out of the denominator so that we can actually solve for Vs. So we start off by multiplying by it, and we get 755,56 multiplied by 340 minus Vs. All right, so we move it up, is equal to 340 multiplied by 680. Now that we've done that, we would like to get rid of the 755,56 on the left-hand side of the formula. So we're going to divide by this value, by this 755,56. When we do so, we end up with that value on the right-hand side, 755,56, and we are dividing by it on the right-hand side. Now on the left-hand side, we need to get rid of the 340. So we're going to subtract it, right? So we move it over, and on the right-hand side, we have minus 340. That is not part of the fraction, it's on the outside. Lastly, we need to get rid of this negative. So we take everything and we're going to divide it by -1 to get rid of the negative, and that is going to give us Vs. You can take as many steps as you need to come to this answer. You don't need to write it all out at once. You can put it into your calculator, write down the value that you obtain without rounding off, and continue in many steps. In the end, we find out that the speed of the source is 34 meters per second. That is the final answer to this question. The marks will be allocated as follows. So this is a question out of 5 marks. The first mark you're going to obtain for calculating this over here. So over here where you calculated the frequency that the detector detects, okay, we're going to get 1 mark over there. Then when you are done with that, you wrote down the Doppler effect, you get 1 mark for the Doppler effect. After the Doppler effect, you have to put or substitute values into the formula, directly into the formula before manipulating the equation. You're going to get 1 mark for this section of your substitution and 1 mark for the 680 in the place of Fs. So we are now on 1, 2, 3, 4 marks. The last mark you're going to obtain for the speed that you were required to find. So I'm just going to highlight them for you. It's a mark here, there, and there. That is your 5 marks for question 6.4. And that brings us to the end of this question, which is out of 12 marks. Grade 12s, we've reached the end of this video. In the next video, we're going to move on to a question number 7, that actually deals with grade 11 work. That is electrostatics, that was taught in grade 11 but is tested again in matric.